Alright, let's go over some examples. I should give a quiz, shouldn't I? Yeah. Just as long as it's turned in tomorrow. Yes. 9:41. Alright, so let's say we have a roller coaster. Let's say it is 50 kilograms. And it starts at a height of 10 meters. And it goes down this slope and makes a loop-de-loop. This loop-de-loop is 5 meters tall. My question is, once it slides down, how fast will it be going at the top of this loop? So how fast will the box be traveling at the top of the loop? So the box is going to slide down, go under the loop, and continue moving. Eventually, it'll come on this flat portion and be moving at some speed. So, in solving these problems, we do a before and after. Before, we have total energy, total mechanical energy. The total energy is going to be equal to kinetic energy plus potential energy. So what's the kinetic energy of this box at the very start? 0. It's not moving, so we can get rid of the kinetic energy. What's this potential energy? Hello? Alright. Bye. So what's the equation for potential energy? And this would be due to gravity. And what's that equal to? Better to put mass times acceleration times height. So what's this mass? Mass is 50 kilograms. G, we'll assume, is 10 meters per second squared. Let's state it otherwise. We're on Earth. And what is this height? 10 meters. So its total energy beforehand. 50 times 10 times 10. So 100 times 50. So that's 5,000 joules of energy. Alright. So now let's look at the after. So after, the total energy is going to be equal to the kinetic energy plus its potential energy. So what's the equation for kinetic energy? Alright. And what about the potential energy? mgh. So it's 1/2. Mass is 50. We don't know its speed. It's moving at some speed, v. So we can just plug in v squared plus its mass. Its mass is 50. G is 10. And its new height is 5 meters. So half of 50 is 25. I'll keep it written like this for right now. So 1/2 mv squared plus 50 times 10 times 5. 2,500. So the left-hand side has to equal the right-hand side. So that's 5,000 joules is equal to 1/2 times 50 times velocity squared plus 2,500. If you have a plus on the right side, we can subtract both sides. So let's subtract both sides from 2,500 from both sides. So 5,000 minus 2,500 is just 2,500. 2,500 minus 2,500, that disappears. And we have an equation like this. 1/2 times 50 times velocity squared is equal to 2,500. So if you remember those list of equations I gave you yesterday, I don't have a copy with me. Do y'all have it written? So if you have an equation like this, how can you solve for v? So square root of 2 times 2,500 divided by, yes? I'm teaching. I'm not doing the homework. So if you have 1/2 times a mass value times velocity squared is equal to joules on this side, you can use that table I gave yesterday and figure out the equation. Okay. So solving this, we see that the speed is 10 meters per second. So when using that table, it has to be in this form. It has to be some energy value is equal to 1/2 times the mass value times velocity squared. And if it's in this setup, you can use that table I gave you to solve for velocity. That's the reason why I didn't go ahead and immediately multiply a half times 50. So, it starts out moving at 0 meters per second, and then it comes all the way down gaining speed, makes a loop-de-loop, and right here is moving at 10 meters per second. My new question is, how fast is it moving at the very bottom? So here, how fast is it moving here? So again, setup is the same way. We can do a before, and we can do an after. Or after has to be right here because that's what we're trying to solve for. However, our before could be at any single point. But it doesn't really matter because the total energy doesn't change. We already solved for the total energy. The total energy is 5,000. So we can put in that the total energy is equal to 5,000 joules. The total energy right here is 5,000. The total energy right here is 5,000. And the total energy right here is going to be 5,000. Total energy does not change over time, as long as we ignore friction. Total mechanical energy doesn't change over time if we ignore friction. Actually, write that. This is supposed to be mechanical. Because total mechanical energy doesn't change. Some of the mechanical energy, if we have friction, can be converted into thermal, but we ignore friction. So let's look at our after. So the total mechanical energy after again is equal to kinetic energy plus potential energy. So look at the potential energy here. It is currently on the very bottom, so I can let this be 0 meters. Its height above the ground is 0 meters. So it has no potential energy. All of its energy has to be in kinetic energy. And so we have 1/2 mass times velocity squared. And these two things have to be equal. So 5,000 joules has to equal 1/2 mv squared. And this is the setup for the equation. Looking at the table I gave you yesterday, velocity is equal to the square root of 2 times kinetic energy divided by mass. So the kinetic energy, or the energy, has to be as 5,000. Its mass was 50. And so that is equal to the square root. 5,000 divided by 50, 100. So 2 times 100. Square root of 200. And we get a speed of 14.14, 21 meters per second. Y'all make sure y'all are wearing those masks. So, if we were to look at this, so this is at start, top of loop, and the end. We have a height. So it starts here at 10 meters. Here it's at 5 meters. Here it is at 0 meters. We can calculate potential energy from this. It's mgh. And we saw that the potential energy is 5,000 joules. Here we calculated that the potential energy is 2,500 joules. And at the end, 0. If we look at velocities, the velocity at the start is 0 meters per second. The velocity at the top of the loop we calculated was 10 meters per second. And the velocity at the end of the loop is 14.1421 meters per second. And we calculated the kinetic energy. So the kinetic energy at the start was 0 joules. The kinetic energy in the loop, so we calculated that the kinetic energy right here was equal to, let's actually calculate that. So the kinetic energy is 1/2 mass times velocity squared. That's 1/2 times 50 times 10 squared. Half of 50 is 25 times 100, so 2,500 joules, which is actually what we calculated right here. Kinetic energy was equal to 25 joules. And at the very end, the kinetic energy, looking at it, kinetic energy was equal to 5,000 joules. And if we look at total mechanical energy, it's just equal to kinetic plus potential. That's 5,000. Kinetic plus potential, 2,500 plus 2,500 is 5,000. And here, kinetic plus potential is 5,000. So total mechanical energy stays constant. Everyone good? So let's do another example. So I'll let this be 0 meters. This be 20 meters. this height be 8 meters, and this height be 5 meters. I'll call this point A, B, C, and D. And let's let it be a ball of mass. Oh, let's do 10 kilograms. Make it easy. So point A. I've had them all. And 7, cool. 1. Yes. Once Amanda gets back. Okay, so let's look at height for all of these. So what is the height of A? 20 meters. Height of B? C? 8. And then for D, 5 meters. What is the velocity now of each one? So we'll assume that it starts at 0. So, and at rest up here. B, C, and D, we don't know yet. Let's do potential energy. Kinetic energy. And total mechanical energy. So, what is the kinetic? Well, if the velocity is 0, the kinetic energy is 0 joules. For B, we're at the ground. So, if we're at the very bottom, our potential energy is 0. And currently, that's all we know right now. So, let's try filling in this table. I would start with this one. It's the most easiest. So, at point A, its potential energy would be equal to mgh. So that would be equal to mass 10 kilograms times g, which we'll assume is 10 meters per second squared. Its height is 20 meters. And so that would be 100 times 20, 2,000 joules. So we can come fill it up into the table, 2,000 joules. So what is the total mechanical energy for A? 2,000. Now, here's the trick. All the rest of it has to be equal to 2,000 joules. So then, if the total is 2,000 and the potential is 0, what would be the kinetic energy? 2,000. Let's worry about the velocities last. Let's look at B's potential, or not B's, let's look at C's potential energy. So the potential energy is equal to mgh. So looking at C, again, the mass is 10 kilograms. G is 10 meters per second squared. Height is 8 meters. So that would be 100 times 8, so that's 800 joules. So let's go ahead and fill it in this table, 800 joules. Well, if total is 2,000 and potential is 800, then kinetic energy must be 1,200. And let's look at D. D's potential energy is equal to mgh. So mass, again, is 10 kilograms. 10 meters per second squared. And the height was 5 meters. So that's equal to 500 joules. So this is for potential energy of D. So we can come over here and put in 500 joules. What is the kinetic energy? 1,500. So now let's go back and solve for all the velocities. So for B, we know that kinetic energy is equal to 1/2 mass times velocity squared. And using that formula, velocity is equal to the square root of 2 times kinetic energy divided by mass. Look at this nice table. This nice table tells you your kinetic energy, tells you your, I could have put in mass. Mass is 10. I should probably have put that into the table. Let's see if I can squeeze it somewhere. Yeah. Mass, 10 kilograms, 10 kilograms, 10 kilograms. I could have also squeezed in G and other things, but look. We have kinetic energy. Kinetic energy is 1,200, so square root of 2 times 1,200. And divide by the mass of 10 kilograms. So this is equal to the square root of 2,400 divided by 10, which equals square root of 240. Which is equal to 15.4919 meters per second. So we can come squeeze that value in right here. And this is for B. My bad. This was for C. I use C's value. Be careful on which values you're using from the table. So I use the kinetic energy of 1,200. So this would go in the 1,200 table. Well, let me ask you something. Which do you think is easier? Doing this before and after? Or making this nice table? Before and after? So here we have to do a whole bunch of complicated stuff. I recommend we stick with the table method. Because now we can, so let's now go back to B. So B's kinetic energy equal to 1/2 mv squared. That's how, no, because you could have a table. So you could have a table like this that is literally before and after. And then you can fill out the table right here. So I recommend not trying to do the complicated math like I did in the first example. I highly recommend you make a table of before and after, and you fill all these points and just recognize it like this. So this first example, we solved it more mathematically. This is closer to algebra. This one doesn't require algebra when I give you this equation. So looking at C, this is the square root of 2 times kinetic energy divided by mass. So here we can look at for B, the kinetic energy was 2,000. The mass is 10 kilograms. So that'd be the square root of 4,000 divided by 10, which is equal to the square root of 400. Which is 20 meters per second. And then you can come over here and plug in 20 meters per second. So I will give problems that will ask you to find it. Usually they're multi-step like this. But I highly recommend you do this table method. In which case you're finding all this information at each point. Because once you get your equation for B, it's velocity is equal to square root of 2 ke divided by m. Here's your ke, here's your mass, and you can plug it in. So the general strategy for this, and let's go ahead and do D. D, the velocity is equal to square root of 2 times 1500 for the ke, divided by the mass of 10. So that'd be the square root of 300. Which ends up being 17.32 meters per second. So the general strategy is create a table, plug in heights, identify at rest, so when v equals 0 meters per second. Potential energy is equal to 0 joules if height is equal to 0 meters. Kinetic energy solve for total mechanical energy. I should say, skip a step. Number 3, solve for potential energies using potential energy as GH for each segment. Find one segment you know kinetic energy plus potential energy to get total mechanical energy. By the way, total mechanical energy is equal to kinetic energy plus potential energy. And then solve for velocities using velocity is equal to the square root of 2 times KE divided by mass. So this is the general strategy for solving these problems that I recommend. Create a table, plug in heights, identify at rest. If it's at rest, K equals 0. Identify 0 heights. So PE equals 0 joules if the height is 0. Then solve for the rest of the heights using the rest of the potential energies using the equation mgh for each segment. Then identify one of them where you know, for example, that the potential energy is 2000, the velocity is 0. And I will say, then set all TME, because it's constant, to this value. Does that make sense? Now I'm going to do a slightly more difficult problem, but you'll see that this table makes it a whole lot easier. Everyone good? Make sure you are putting on your mask. Alright, so we have what was that? I don't know. So we have, let's say that we start with a box that is 5 kilograms. I'm going to label this A, this B, and this C. The box is going to slide down. Eventually it's going to move downward here, and it's going to be moving at some speed, and eventually it's going to slide down again, and it's going to also be moving at some speed. Note, I didn't give you the height here. Let's see if we can solve it though. So we have segment A, segment B, segment C. So this is height. Actually, I'm going to make this mass. This is height. This is velocity. I really could have also plugged in G to this table, but it's constant. This is potential energy. This would be kinetic energy. And this would be total mechanical energy. Alright, so we begin by plugging in everything we possibly know. 5 kilograms given. The mass doesn't change with time. I could have also squeezed in G. G also doesn't change with time. It would be 10. Really wish I did it, but I don't really want to squeeze it in. So let's plug in heights. So 25 meters. We don't know B's height, but we know C's height is 0 meters. It might not be. Oh, I'm going to give you that this is moving at, let me actually, I left off one bit of information. Let's let this one be moving at 10 meters per second here. There we go. So I don't know height, but I know its speed. So now let's plug in the speed values that we know. I'll assume that this one's at rest here. It starts at rest. So I can plug in 0 meters per second here. I tell you that this one's at 10 meters per second. And this one right here we don't know. So we don't know the height of B, and we don't know the height of C, or the velocity of C. So now let's start doing finding our zeros. If velocity is 0, kinetic energy is 0 joules. So if the velocity is 0, then the kinetic energy is going to be 0. If the height is 0, potential energy is 0. So if height equals 0 meters, potential energy equals 0 joules. If velocity is 0 meters per second, kinetic energy is 0 joules. So now let's try solving for all the potential energy we can solve for. So if you know mass, G, and H, you can solve for potential energy. So let's look at all the ones we know potential energy for. We have a height, we have a mass, and we know G. So looking for A's potential energy equal to mgh. That'd be 5 times G is 10, and its height is 25. That is 1250 joules. So we can plug it in. Potential energy for B. Yeah, you're right. We can do that. But look at potential energy for B. Do we know its height? No, so we can't solve for it. So we don't know that. Now let's look at total kinetic energy, or total mechanical energy. If we know kinetic energy and potential, we can add these together. Now let's look at kinetic energy. If you know mass, velocity, so if you know mass and velocity, you can calculate kinetic energy. So are there any any values that we know mass and velocity? Well, that would be B. Also, for total mechanical energy, we can go ahead and write this over. So we know velocity and we know mass. Yeah, but we already solved for it. We don't need to solve for it. But you are correct. 1/2 times 5 times 0 squared is 0. Yes, we can do that later. And the point table though is that you can do it in any order. We're just finding ways to fill this table out. So if we look at B we know that kinetic energy is equal to 1/2 mass times velocity squared. So that'd be 1/2 times 5 times 10 squared. And that's equal to 250 joules. Now then, potential energy, what plus 250 gives you 1250? 1000 joules. And 0 plus what gives you 1250? And now all we need is the height and velocity, which you can use that table of formulas I gave you last time to solve for. The code word for the day. So here's the code word of the day. And that's it for the day.